Assalamualaikum everyone, I hope you guys are doing well. So as you know, we're in the process of covering combinations, and what we did, I think in the last videos that we did, actually in the video before that, we did an introduction of what combination is, and then we did type 1, and now just like how we did permutations, we're going to look into some specific conditions that you will find commonly in combinations, and then we're going to be learning how to solve questions that involve those conditions or restrictions, whatever you want to call them. So this is type 2, where you will see combination is being applied to people or objects, and the condition would be that a certain object or a certain person must be chosen. Okay, could be more than one, could be more than two. We'll find out as we go along. So here are some past paper questions. So we're going to solve around 4 or 5 past paper questions to learn this concept. And before I get into the video, if you're new here and you haven't subscribed to the channel, well, please do so, and make sure to like this video and share this with whoever you think can possibly benefit from it. Another announcement that I would like to make is that my S1, P1, M1, P3 past paper session is starting from the first week of April. So you can register for it directly from the website www.mathletebysart.com. We'll be solving yearly past papers, and alongside, I'll be giving you tips and tricks such as how to manage your time and what are the important topics and what weightage they carry. So now let's get into this video and let's solve this question. So it says Freddy has 6 toy cars and 3 toy buses, all different. He chooses 4 toys to take on the holiday with him. How many of these choices, so it's a little misprint here, will include both his favorite car and favorite bus? Okay, so first of all, let's just get familiar with the question. Okay, so by that I mean, how many objects do we have to choose from and how many objects do we have to choose? So altogether there are 9 objects to choose from. Okay, and they're all different, even though they're toy cars, but they're all different. Why? Because the question says so. And he has to choose 4 toys, and these 4 choices must include both his favorite car and his favorite bus. So that means when he is, so think of it this way, think of it as if you're Freddy. You have 9 cars in front of you. Now he has to choose 4, but he knows that he knows very well that a certain one toy car and one toy bus has to be there. So he's gonna put those on the side, and now he just has to select 2. Okay, but what will he select the 2? From what or from how many toys will he be selecting the 2? Let's find out. So how do we approach such a question? So here's a standard way to approach questions like these. First of all, let's look at the number of toy cars that he has. So he has 6 toy cars. Okay, now amongst these 6 toy cars, there's one which is his favorite. Okay, so that means this one he's already selected. Now he has 5 remaining. Okay, let's talk about the toy buses. So he has 3 toy buses, and amongst these 3, there is one which he will select no matter what. Okay, so we're just going to put a check mark, and there are 2 that are now left. Now, if you talk about the number of toys that he has to select, that happen to be 4. So there are 4 toys that he will choose, correct? Okay, that's not how you spell choose. Now, if you think about it, technically he's already selected 2. Isn't that so? Technically he's already selected 2. How is that? Here's how. So the one toy car must be selected. So how do you make sure that one object is selected? You can do 1C1. Now, even if you don't do that at all, it really doesn't make a difference. I'll show you why. And then how do you make sure that the one toy bus is already selected? You do 1C1 again. Okay, so this is for the toy car. This is for the toy bus that must be selected. Okay, now he still has to select 2 more. Okay, so he selected 2. He still has to select 2 more. Now the question is, yes, he has to select 2, but the question is, out of how many should he be selecting these 2? So notice that there are still 5 toy cars left to choose from, and there are still 2 toy cars left to choose from. And how many does he have to choose? He has to choose 2. So how many ways can you select 2 objects from 7? Now, because there is no condition over here, he can have, as many, after this condition has been met, this restriction has been, fulfilled, then there is no restriction. So that means we're just going to combine them. We're going to combine the toy cars and the toy buses, and from that combined number, we're going to select 2. So how can you do that? 7C2. That's it. Now, I was saying that even if you don't do 1C1 times 1C1, it doesn't make a difference. Why? Because it's 1 anyway. There's only one way to select one object, and there's only one way to select the other object. So even if you don't do it, it doesn't make a difference. You get the right answer. But it's good to do this. I personally recommend it so that you can really see one by one how you've met the conditions or how you're fulfilling the restrictions that is mentioned in the question. Okay, so I personally prefer it if you ask me. So 7C2, which is equal to 21, that's the answer. So 2 I wouldn't say very easy marks, but also not too difficult either. Now another question, which says a group of 6 people is to be chosen from 4 men and 11 women. So it's very important that you first read the question thoroughly so you're very well familiar, or you're very well aware of what it is that the question has given and what it is that the question is expecting from you. In how many different ways can a group of 6 people be chosen, or a group of 6 be chosen, if it must contain exactly 1 man? That's it. So there's got to be 1 man, and if you're selecting a group of 6, that means the remaining 5 must be women. So let's talk about the number of people that we are selecting, which happens to be 6. So we have to select 6 people. Now the condition is that in these 6 people, there's got to be 1 man. That's it. Okay, it says exactly 1 man. It doesn't say that it must include 1 particular man. No, it says that there's just got to be exactly 1 man, not more than that, not less than that. So that inevitably means that the remaining 5 will be women. Okay, now let's look at the number of people that we have. So we have 4 men to choose from, and we have 11 women to choose from. Now from these 4 men, we're just going to choose the 1, which means from these 11 women, we're going to choose the remaining 5. Okay, so from the 4 men, we're just going to choose 1, and that means we still need to make a group of 6, right? So from the remaining 11, we're going to select the remaining 5. Okay, so how do you do that? 4C1 times 11C5. Let's work this out. Let's see what we get. 4C1 is 4 times 11C5. So we are looking at 1848. 1848, and that is the correct answer. So I hope you're following. Now at this point, I will start encouraging you to pause the video, attempt the question yourself, and then see if you're getting the correct answer or not. So this question says that 26 members of the local sports club include Mr. and Mrs. Khan and their son. Okay, I don't think I need to underline all of that, so let's just underline 26. Okay, so we have Mr. and Mrs. Khan and their son Abad. The club is holding a party to celebrate Abad's birthday. Okay, now a lot of this you will notice is just completely irrelevant backstory. It's just trying to confuse you, or it's just trying to show you how this concept has real life applications. Okay, so don't get confused, don't get intimidated. This question could very well be a 2-line question. Okay. So, but there's only room for 20 people to attend. So that means 26 members cannot join, with only 20 can join. So that means some people have to miss out. Now, in how many ways can the 20 people be chosen from the 26 members of the club, given that, so we have 26 members, given that Mr. and Mrs. Khan and Abad, her son, obviously, he better be there, it's his birthday, must be included. Okay, now, so let's pause for a minute. Let's see how many people we have to select from. We have 26 people to choose from. How many people do we have to choose? We have to choose 20. But 3 people must be included. Okay. So that means if you have 26 people to choose from, and you know for sure that 3 people must be included, that means you really don't have 26 people to choose from. You technically have 23 people to choose from. Why? Because these 3 are going to be there anyway. So you're not just going to set them aside and be like, okay, here are the 23 people. I need to decide. I need to basically decide from these people. Okay. Then if you look at the number of people that you have to choose, so you have 20 people to choose. But if you think about it, technically you've already chosen 3. Okay, Mr. and Mrs. Hassan and Abad, their son. So that means 3 people have already been selected. That means now your job is to simply select 17, the 17 in order to make a group of 20. So technically all that you're doing is you're selecting out of 23 people, you're selecting 17. Okay, so what's the working behind that? 3C3 for what? 3C3 to show Mr., Mrs., so Mr., Mrs. and Abad, to show how many ways you can select 3 people out of 3, which is as good as 1. So even if you don't do this, you're still good to go. Multiplied by 23. Why? Because you have 23 people left after you've excluded these 3 from the group, and you have to select 17. Why? Because now you only have to select 17, considering that you have already selected how many people? Considering that you've already selected 3 people. So let's work this out. 23C17. Notice I just ignored 3C3 because it's as good as 1. So the answer is 100,947. And there you go. That's the answer. So, this question could have very well been the following. Could have been, how many ways can you select 23 people from 26, given that 3 people must be in the group, or 3 people must be selected. There you go. It could have been not, I said two-liner question, but it could have very easily been a one-line question. But the question sometimes likes to give you the backstory to, borderline confuse yourself, but to also show that there is a lot of application of this concept, okay? So, anyway, hope it's clear. Now let's do the next question. So this question says, hang on a minute, let me put my phone on silent. So this question says, find the number of ways in which a committee of 6 people can be chosen from 6 men and 8 women if it must include 3 men and 3 women. So that means 3 men, 3 women should make the group of 6. That's it. So how many men do we have? We have 6 men to choose from, and we have 8 women to choose from. So from these 6 men, we want to choose 3. Okay, so from these 6 men will come 3 men, so that means 63. And from the 8 women, we must choose 3 women. So how can you do that? That's 8C3. So let's work this out. Pretty easy, no? 63 times 8C3, which is equal to 1,120. Let's see if that's the correct answer. Yep, that is the correct answer. Okay. Now, this is the question that I saved for the last. Why? You'll find out. So, and as always, I encourage you guys to pause this video, attempt this question yourself, but make sure you read the question thoroughly, okay? It has it's basically probability. So it says a committee of 6 people, all right, let's underline that, which must contain at least 4 men and at least 1 woman, is chosen from 10 men and 9 women, okay? Find the probability that one particular man, Albert, and one particular woman, Tracy, are both on the committee. Now, you've noticed that the marks I've given over here are 3 plus 2. Why? Because there was a part of this question where you just had to find out how many ways this is possible, that you choose a committee of 6 people, which must contain at least 4 men and at least 1 woman. So this was a separate 3-mark question, and then you had to find this out. Okay, so because we've combined them into one, that's why this overall becomes a 5-mark question. Now, let's read the question. We've read the question. Let's dive deep into the question and see what we're dealing with. So we have to select 6 people. Condition is that there must be at least 4 men and there must be at least 1 woman. Okay, so if you think about it, that means we can have 4 men and 1 woman. Okay. No, wait a minute. Not 4 men and 1 woman. We can have 4 men and 2 women. That way you make 6. That way you make a group of 6. And another way would be that you have 5 men and 1 woman. Okay, so you have to keep this at the back of your mind. The 2 ways that we can do this, we can meet the condition which is at least 4 men and at least 1 woman, is if you have 4 men and 2 women, and if you have 5 men and 1 woman. Okay, so keep this at the back of your mind, like I said. Now, the condition is that one particular man, Albert, and one particular woman, Tracy, are both on the committee. Okay. Now, we have 10 men to choose from and 9 women to choose from. Now, if I have to select Albert, that means that from the 10, Albert's already selected. How do I make sure Albert's already selected? So there's one Albert, okay, and we have to make sure that he's selected. Okay, that means now we have 9 men remaining. Okay, now we have 9 men remaining. Now, what I'm focusing on right now is basically this part where we select. Okay, let me make some room. Yeah, so what I'm focusing on right now is basically this part where we select 4 men and 2 women. Okay, where we select 4 men and 2 women. Now, notice that if Albert's already selected, that means I still have to choose 3 more men. Okay, I still have to choose 3 more men. Now, the question is, where will those 3 men come from? Those 3 men will definitely come from the remaining 9 men. So that would be 9C3. Okay, so once again, we have to select 4 men and we have to make sure that Albert's already selected. So we have 10 men to choose from. So Albert's already selected. Let's put a check mark here. That means the remaining 3, because we still have to select, overall there should be 4 men, right? So the remaining 3 will come from 9. Okay, so we're settled as far as the men are concerned. Now, let's talk about the women. How many women do we have? We have 9 women. Now, as far as these 9 women are concerned, we have to make sure that Tracy is already selected. Okay, we have to make sure that we select Tracy. So if Tracy is already selected, how can you do that? There's one Tracy and we have to select her, so that's 1C1. Now, notice that we still have to select 1 more woman in order to make sure that there are 2 women altogether. So that means there are 8 women now left, and from these 8 women, we need to select 1 more. So that would be 𝐻𝐶1. Okay, so once again, I want you guys to take a very good look at this. So we have, overall, we have to select 4 men and 2 women, but the condition is Albert must be included, and Tracy, who's a woman, also must be included. Okay, so if Albert's already included and you have to select 4 men, that means now you have to select 3 more men, and 3 more men from the remaining 9 men. Similarly, if there are 9 women and 1 woman whose Tracy is or must be included, that means you still have to select more in order to reach the number of 2 women, and you will be selecting those 2 women from 8 remaining women. Now let's work this out. Let's see what do we get. So we can very well ignore 1C1 and 1C1. So I'm just going to do 9C3 into 8C1. So that's equal to 672. Okay. So that means one way to select at least 4 men and at least 1 woman, given that Albert and Tracy are both in the committee, is that we select 4 men and 2 women, and we've dealt with that. Okay, now let's focus on this. Let's drag this up. Let's focus on selecting 5 men and 1 woman while making sure that Albert and Tracy are selected. So we have 10 men to choose from. We want to make sure that Albert's selected. So that's 1 Albert, okay, and if he's selected, that's 1C1. That means from the remaining 9, now I will select how many? Remember that we have to select 5 men altogether. Albert's already selected. That means now we have to select 4. So 9C4. Now Albert's already selected and 4 more men already selected. So that means altogether 5 men have been selected. Now let's talk about the women. As far as women are concerned, there's 1 Tracy who must be selected. Okay, so that's 1C1. So Tracy is selected. Okay, this is for Tracy, this is for Albert. Now the remaining 8 women. So from the remaining 8 women, what should we do? Well, we just have to include 1 woman. That's it. And we've already done that. That means from these 8 women, you don't need to include any one. So you could do 𝐻𝐶0, you could not do anything at all. It really does not make a difference because 𝐻𝐶0 is as good as 1. So let's work this out. 1C1 into 9, 1C1, which I can just ignore. So technically, we just have to do 9C4, which is equal to what? Which is equal to 126. So that means the total number of ways that we can select at least 4 men and at least 1 woman, given that Albert and Tracy are both in the committee, is equal to what? Is equal to 126 plus 672, which is equal to 798. Now, you're probably thinking this is the end of the question. Well, it's actually not. Why? Because what we have worked out are these 798 are the number of favorable outcomes. Okay, so these are your favorable outcomes. Now, why do we want favorable outcomes? Because as you know, all of probability revolves around one formula and one formula only, which is the number of favorable outcomes divided by the number of total outcomes. Now, the question is, what are the total outcomes? Well, let's focus on that now. So as far as the total outcomes are concerned, in the total outcomes, we don't care who's being selected. In the total number of outcomes, we only have to make sure that the main condition, which is at least 4 men and at least 1 woman, is taken care of. Okay, so let's go back. If the main condition is that there's got to be at least 4 men and at least 1 woman, so we already know how to do that. We already know that can be 4 men and 2 women. That's possible. And how do you make sure that you have 4 men and 2 women? So that would be the total number of men, which happen to be 10, from which you're only supposed to select 4, and the total number of women, which happen to be 9, from which you're only supposed to select 2. So that's one way. Okay, the other way, let's make some room here. Okay, the other way is, so this is one way. All right, the other way is that, as we saw earlier, that we have 5 men and 1 woman. How can you do that? How can you have 5 men and 1 woman? So 10 men to choose from, you have to choose 5. So that's 10C5. 9 women to choose from, you have to choose 1. That's 9C1. Okay, so here we're not concerned who's getting selected and who's not. We just have to find out the total number of outcomes. So let's work this out. So 10C4 into 9C2, that's equal to 7560. 7560. And then 10C5 into 9C1. might as well ignore, sorry, no, we can't ignore 9C1. I thought it was 1C1. So that's equal to 2268. Now let's work this out. 2268 plus 7560, that's equal to 9828. Now let's find out the probability, which will be equal to 798 divided by 9828, which is equal to 798 divided by the answer, that's equal to 19 upon 234. And my suggestion is, because it's not a terminating decimal, to leave it as it is. And this, fellas, is the correct answer. All right, so I hope you enjoyed this question. Understanding it is one thing, but I really hope you enjoyed this question, because questions like these are fun to solve, as long as there's not a lot of pressure. When there's exam pressure, these questions can be annoying, but we still have to learn them one way or the other. So that's it for this video. In this video, as you know, we dealt with the restriction or the condition where one particular person or object or whatever must be chosen. In the next video, we're going to deal with a very interesting condition, and that is cannot be separated. So you'll have a husband and wife who must not be separated, or even must not be together. So interesting. Okay, so we're going to look into that inshallah in the next video. So I'll see you guys then. Take care. Allah Hafiz.